Developers and continuous integration, continuous deployment, CI/CD. Welcome to our channel, where we dive deep into all things related to continuous integration and continuous deployment. Developers and continuous integration, continuous deployment, CI/CD, play a critical role in modern software development. CI is a set of practices that enable developers to streamline the process of building, testing, and deploying software. Here's a detailed look at how developers contribute to CI/CD. Before we begin, make sure to smash that like button and hit the subscribe for more exciting content. 1. Version control. Version control is a fundamental aspect of modern software development, providing a structured and organized approach to managing source code. It enables developers to track changes, collaborate effectively, and maintain a historical record of code evolution. Using version control systems like Git, developers can create branches for different features or bug fixes, work on them independently, and later merge these changes back into the main codebase. This process ensures that code modifications are traceable and reversible, minimizing the risk of introducing errors into the production environment. Additionally, version control facilitates collaboration among development teams, allowing multiple developers to contribute concurrently while maintaining code integrity. In summary, version control plays a pivotal role in ensuring code quality, collaboration, and the successful implementation of continuous integration, continuous deployment, CI/CD practices. 2. Code quality. Code quality is a critical aspect of software development, encompassing various principles and practices aimed at producing clean, maintainable, and efficient code. High-quality code not only enhances the reliability and performance of applications, but also simplifies the development process itself. To achieve code quality, developers adhere to coding standards, maintain consistency in their code base, and follow best practices in design and architecture. They also conduct thorough code reviews to identify and rectify issues such as code smells, security vulnerabilities, or inefficient algorithms. Code quality is closely tied to the success of continuous integration, continuous deployment, CI/CD, pipelines, as it ensures that code changes can be seamlessly integrated, tested, and deployed without causing disruptions. In essence, prioritizing code quality is fundamental to building robust and sustainable software systems. 3. Unit testing. Developers write unit tests to verify the functionality of individual code components. These tests are integrated into the CI pipeline, providing rapid feedback on code changes. 4. Integration testing. Integration testing is a pivotal phase in the software testing process, focusing on verifying the interactions and interoperability between different components or modules within an application. Unlike unit testing, which tests individual code units in isolation, integration testing evaluates how these units collaborate and function together as a whole. This testing phase is essential to ensure that various software components can seamlessly exchange data, communicate, and perform their intended functions within the integrated system. Integration tests often identify issues that may not be apparent during unit testing, such as data inconsistencies, interface mismatches, or communication problems between modules. By conducting integration testing as part of the software development lifecycle, developers can catch and rectify integration-related bugs early, contributing to the overall reliability and stability of the application. 5. Continuous integration CI. Developers trigger CI pipelines whenever they commit changes to the version control system. CI servers automatically build the application, run tests, and report any failures, helping to catch issues early in the development process. 6. Automated builds. Developers configure build scripts or use build automation tools to package their code into deployable artifacts. This ensures consistency and repeatability in the build process. 7. Artifact repository. Developers store build artifacts in a repository, making them accessible for deployment and ensuring traceability. 8. Containerization. Developers may containerize their applications using technologies like Docker. This makes it easier to deploy and manage applications across various environments. 9. Deployment automation. Developers define deployment scripts or use infrastructure as code tools, Terraform, to automate the provisioning and configuration of infrastructure resources. 10. Continuous deployment, CD. Continuous deployment, CD, automates the deployment of code changes to production if they pass automated tests. This practice accelerates software delivery, enhances agility, and streamlines the release process. CD requires thorough testing, monitoring, and rollback plans to ensure stability and user satisfaction in real-world environments. 11. Monitoring and observability. Developers instrument their code with monitoring and logging to gather insights into application behavior. They use these insights to identify and address issues promptly. 12. Rollback and roll forward. Developers work on strategies for rolling back to previous versions in case of issues and rolling forward to new versions after problems are resolved. This is a crucial part of CD pipelines. 13. Feedback loop. Developers continuously improve the CI/CD process by analyzing pipeline results and seeking ways to optimize build and deployment times. 14. Security. Security is a top priority in the CI/CD process. Developers and DevOps teams continuously assess and mitigate vulnerabilities using security testing and access controls. Integrating security measures into CI pipelines ensures robust protection against threats and data breaches, maintaining trust in software products. 15. Collaboration. Developers collaborate with DevOps and QA teams to ensure the smooth operation of CI pipelines and to coordinate release schedules. 16. Documentation. Developers maintain documentation for the CI process, including pipeline configurations, deployment procedures, and troubleshooting guides. In summary, developers are central to the success of CI pipelines. They are responsible for writing quality code, creating and maintaining tests, configuring automation scripts, and ensuring that the software is continuously delivered to production environments in a reliable and efficient manner. Their collaboration with other teams and their commitment to ongoing improvement are essential components of a successful CI culture. If you find our videos helpful, don't forget to share, subscribe, and hit the like button to support our channel.